So all that magnetic data that we looked at led one scientist, Harry Hess, to really kind of put all of this information together. So in 1960, Harry Hess wrote a book called The Essays in Geopoetry, and he really looked at the seafloor. So Alfred Wegener really concentrated on what was going on with the continents, whereas we're going to see here Harry Hess really concentrated on what was going on the seafloor. So Harry Hess noticed, as we've already discussed, that sediment is going to get thicker towards the edge of the continents, right, away from the ridges. So, right, if you're in the center of the ocean, right, the sediment is going to be very thin there, right? You're not going to find a whole lot of it. At the mid-ocean ridge, there's a lot of earthquakes there, as we've also talked about. So this indicated to Harry Hess that the ocean floor was actually breaking there, that it was cracking, and that high heat flow that was measured at that ridge is actually molten rock, right? Magma that's coming out from inside of the earth and coming out through that crack itself. So he called this idea seafloor spreading. He basically thought that the seafloor worked like a conveyor belt, which he isn't really wrong at all. That new ocean crust is created at the ridge and it moves away. So as you can see here, right in these arrows, new magma is rising up and it's moving laterally, right? It's coming up and it's pushing, right, this material away. So this indicated to Hess that the seafloor is actually getting bigger over time, right? And that's why he called it seafloor spreading. Now clearly there has to be a mechanism to destroy crust, because we know the Earth's volume isn't just getting bigger over time. So he also, right, then took a look at those trenches that we've talked about. And we mentioned this before. So right here in the trench, what he noticed is that the ocean floor is actually diving down beneath the continent. And it's going back inside of the Earth to become recycled. So it's a pretty beautiful thing. Like I said, it acts very much like a conveyor belt, with new material rising up and moving laterally, and old material getting what we're going to call subducted, right, underneath the continent. So what was the evidence, right, that Hess had that showed him this? Because clearly there has to be some evidence to show him. So he looked at those magnetics, right, those magnetics that we looked at just previous here. And what he noticed when he was looking at the magnetics is that over time, okay, what he sees, if you start at the ridge and work your way out, is that there's a pattern of positive and negative anomalies. And that's what you're seeing here in this picture. The black stripes represent a positive anomaly, and the white represents a negative. Basically, a positive anomaly means that the magnetic field is measuring stronger in that region, and a negative anomaly means it's measuring weaker, right, in that region. So he wanted to investigate this further, because what really intrigued Hess about this, and I want you to look at this picture here, is that this pattern, right, this zebra stripe pattern, is symmetrical either side of the ridge. So this side is a mirror image of this side. Now that's pretty important, right? So Hess wanted to take a look at this a little bit further. So when we take a look at this, right, like I said, what we see is positive areas are measuring stronger, right, and negative areas measure weaker. And the way that we record this is by using a magnometer, which is basically what they use on those ghost shows, if you ever watch those on TV. But you can see that it's just being towed behind a boat, and it picks up, right, the signals essentially in the rock. And it's picking up the iron signals, okay, that are in the rock. Because again, as we've already discussed, right, it's got to be rocks that are iron-bearing that are recording the magnetics. Now, the most important part of this, and I'm going to explain here in a minute what positive and negative mean, but is that symmetrical pattern. that symmetrical pattern was really important to Hess because he wanted to figure out how in the world could you get that symmetrical pattern. Because, like I said, as you can see here, that pattern is symmetrical on either side of the ridge. So remember, here's our ridges, and remember they're offset, right, by those transform faults. So let's talk about what positive and negative means first. So what's really interesting is we know today the North Pole reads positive and the South Pole would essentially read negative, right? And that's how your compass lines itself up. However, if we go back in time, what we see is the magnetic field can actually switch. Whereas if I was standing in a period of magnetic reverse and I had a compass, the north, right, the north arrow on my compass would actually point towards the physical South Pole. Now, that doesn't mean that the Earth is flipped upside down or anything crazy like that. It just means that the charges changed. So, right, let's just say the North Pole is negative and the South Pole is positive, and this is normal. In a period of reverse, all that happens is the North Pole becomes positive and the South Pole becomes negative. So if you've got flow of charge that works this way, now it's going to go backwards. And that causes the magnetic field to switch. Now, why the Earth does that, we're not 100% certain. We think it has something to do with the flow of the outer core on top of the inner core, that for some reason maybe it's switching direction. But in any event, we don't really know for sure because we haven't seen a magnetic reversal in human recorded history. So you might be saying, well, how do we know there's been these magnetic reversals? Well, it's recorded in the rocks, right? So here what you see is we've got lava flows, right, stacked on top of each other. And if we take a look at each layer, it's showing us, essentially, remember, those iron minerals line themselves up with magnetic north and south. There are compasses. We can physically see when things have been reversed or when they've been normal. Normal just means it is just like how it is today. So you can see there's been a pattern, right, over geologic time. So we can age date those patterns, which we're going to talk about age dating, the very last chapter we do, how we get these actual numbers. But what's interesting is we can construct a magnetic reversal pattern. You notice there's no real pattern to it, not like, every 10,000 years it switches or anything like that. There's no real rhyme or reason to it. But it switches. These times where there's been a large interval, this is what we call a chron. Where we have short intervals, that's what we call a subchron. So you can see that there's quite a few of these crons intermixed with a little bit of subcrons in there. Now, we need to figure out how this symmetrical pattern happens. So now we can kind of put this into play here. So let's take a look back at our pattern. So what we see here, right, is maybe I've got a negative anomaly, right, and a positive anomaly. So what I'm seeing, right, are these patterns, okay, on either side. And again, they are symmetrical. So this was really the key that led Hess to unlock seafloor spreading and realize that our ocean floors are in motion. So what he determined, and what's actually true, is that over time, right, this new magma comes in and is actually recording the magnetic information. So let's take a look here. So here we are at time 1. At time 1, I've got this magma sitting down here, and it's coming up, and it's coming through that crack, and it's solidifying. So it's going to record an age, right? And not only an age, it's going to record that magnetic symbol, right? So let's just say it's recording a positive. Okay. Now, what happens? And I'm going to come over here and diagram this for you. So let's take a look inside, right? So let's say here we are, right, inside. So we're looking right in here. So this magma that came up here solidified, right? It's a nice solid layer, and it recorded the magnetic information. So let's say it's a positive. Now, what's going to happen here at time 2, right, is we have more magma coming up. So what happens is this magma that's sitting down here wants to come up. So what it does is this layer that formed at time 1 is literally going to crack in half. Half of this is going to go to the left and half is going to go to the right. And then that magma can come in and form a new layer. And maybe that new layer is a negative. And then we get the same thing, right? That negative is going to get split in half, and we're going to form a new one, and maybe that's a positive. So can you see now how, because these layers get split in half every time, half goes one way and half goes the other way, that's how we get that symmetrical pattern. That is the only way we can get that symmetrical pattern. So that is incredibly important to recognize. That is showing us that the seafloor is actually in motion. Remember, in the 1960s, we didn't really have satellites, right, like we do today. Today, we can clearly measure how fast and what direction our plates are moving by using satellites. Back at this point in the 50s and 60s, they didn't have that. So this was the absolute direct evidence to show us that the seafloor is in motion. Now, if we look at that pattern of anomalies, right, across, right, again, recognize that it's mirror image from one side to the other, you'll notice that some of these time periods are long and some are short, and that is completely proportional to the length of the cron. The wider the stripe, the faster the spreading. The more narrow, right, the stripe, the slower the spreading. So it's completely related to how long and how fast that ocean floor was spreading. So today we can drill the ocean floor, and because we can drill the ocean floor, we can get a pretty extensive view here. Here we have the last 170 million years reconstructed with those magnetic reversal patterns. So you can see again, right, there's times where we have long crons, and then lots and lots of subcrons in here as well. So it's pretty neat. And what's really awesome is when we look from one ocean to the other, they all have the same pattern, right? Reinforcing that what we're seeing is an actual magnetic reversal signal.